So we got to the start of this problem yesterday. I would like to finish off this problem right now. So our first check is if it's a triangle or not. So we need to look at, and we did this yesterday, we look at the two shorter sides. The two shorter sides have to add up to be longer than the third side, and it is. 3 plus 5 is 8. 8 is bigger than 6, so we have a triangle. Okay? So we need to find angle A, angle B, and angle C, given the fact that side A is 3, side B is 5, and side C is 6. Okay? Which angle are we going to find first? Angle C. Okay? So let's find angle C, the cosine of angle C, using the formula that we got yesterday. And on your yellow packet, it's in one of the boxes right above this example. That's going to be side A squared plus side B squared minus side C squared divided by 2 times A times B. So in this particular example, that's 3 squared, which is 9, plus 5 squared, which is 25, minus 6 squared, which is 36, all over 2 times 3 times 5, which I wouldn't have to figure that out because I could just type it into my calculator that way. But if I actually do all that math, I get negative 2 over 30. So the cosine of angle C is negative 2 over 30. Which means that angle C then is going to be the inverse cosine of negative 2 over 30. And so then angle C here is 93.8226 degrees. Okay. So now I know that one. Now I'm going to use the law of sines. And the law of sines says that I then find the biggest or smallest? Smallest. So which one's the smallest angle? Angle A. So we would find angle A next. So we would say the sine here of angle C divided by 6 is equal to the sine of angle A divided by 3. Crisscross applesauce, the sine of angle A is equal to 3 times the sine of angle C divided by 6. So angle A here is going to be the inverse sine of that. Which then I get angle A here as 29.9264 degrees. That then allows me to find angle C, not angle C, angle B as 180 degrees minus 93.8226 degrees minus 29.9264 degrees. So then angle B here is 56.251 degrees. Okay. What I would like you to do now is I would like you to try example number 4. First check is if it is a triangle or not. Okay? And so I look at the two shorter sides. Okay? 7 plus 8 is bigger than 10. 15 is bigger than 10, so it is truly a triangle, which is good. So then we have side angle A, angle B, and angle C. Along with that, we have 7, 10, and 8. So which angle am I going to find first? B first, because it's the biggest one. Law of cosine says we go big to small. Okay? So that's going to be then the cosine of B is going to equal A squared plus C squared minus B squared all over 2AC. So that gives me then the cosine of B is going to be equal to 13 over 112. So B, or angle B I should say, is going to be the inverse cosine of that. So I get angle B here as 83.3346 degrees. Now, Molly, you found angle A first, right? Okay. In this case, that's okay because our biggest angle is not obtuse. So there are going to be 3 acute angles, so you lucked out. Okay? But it was only by pure luck that you lucked out. Okay? Right? So, just so you know, if that, because the law of sines won't let us, or finding the smaller angle won't necessarily get us a bigger angle than if we went to the law of sines, because it won't give us an obtuse angle. Okay? So, now I have that. So now let's go to the law of sines. So I would go for angle A now. So the sine of angle B divided by 10 is going to equal the sine of angle A divided by 7. Okay? So crisscross applesauce, the sine of angle A is going to equal 7 times the sine of angle B divided by 10. So angle A is equal to the inverse sine of 7 times the sine of angle B divided by 10. I like to leave everything on my calculator, so that's why I just write it as angle B, but I know it's already on my calculator. And then I got angle A here is 44.0486 degrees. Then now we can find angle C. That's going to be 180 degrees minus 83.3346 degrees minus 44.0486 degrees. So angle C here is 52.6168 degrees. Yes, sir.
Is it okay for like a little off? Because I looked all the answers in my calculator, but I got 44.2369 for angle A.
Did you use answer in degrees?
Oh, degrees.
Yeah. Okay? Because your calculator might be in radians.
I multiplied by 1 million divided by pi.
But when you plug it in here into the sign of B, you got to put the degree symbol. Otherwise, it's going to treat it as a radian.
Okay.
Yeah. Yeah. Good on that? Yeah. All right. So now we're going to switch gears onto that white piece of paper that you got back with law of sines. We're going to do law of cosines problems on the back side of it. Okay? So, a ship travels 60 miles due east. Okay? So, a ship is traveling 60 miles due east. So, my guess is then we'll call this over here, we'll call this its port. We'll say it left from port. Okay. Then it adjusts its course 15 degrees northward. And travels for 80 miles. The question that we're asking is, how far is the ship from its original departure point? So we need to find that length, correct? So let's call that length, what do you want to call it? D, X, Y, Q, X. We'll call that length X. Okay. Is there anything else that I know about this triangle? Yes, ma'am.
You know the angle, the angle on
The obtuse angle?
Yeah, the obtuse angle. There you go. You just do 180 minus 15.
Because they make a linear pair? Yep. So this one is in here is going to be 165 degrees. Agree with that? Okay. Now do I have enough information to solve for x? Yeah? No? What? Oh, no. What was your question? Oh, were you going to jump in? So how am I going to solve for x? Law of cosines, right? Because it's a side angle side case. Okay? So my law of cosines here is going to be x squared is going to equal 60 squared plus 80 squared. I take the two sides of the triangle, I square them, and I add them. Then I'm going to subtract off 2 times 60 times 80 times the cosine of the angle that's in between the two sides. So that's 165. Okay. Eddie, going back to what we just did, I'll calculate this one out. So 60 squared plus 80 squared minus 2 times 60 times 80 times the cosine of 165. Now, if I just leave it like that, it's going to take it as 165 radians. Okay? Even though I already calculated it, even if I would have calculated it before in degrees, I have to put that degree symbol on there to make it be calculated as degrees. Okay? So that's going to give me 19,262.9 as my x squared. 19,272, excuse me, 0.9. I think I might have said 62.9. So my distance to port is going to be, I get 138.827, and our unit was in miles. Yes'm? Anybody not get that? Good catch. Fantastic. What I would like you to do is I would like you to try this next one, 100-foot tower problem. So, we've got a hill at a 6-degree slope. Okay. Little ways up that hill, there is a tower. Right? Okay. So that tower stands 100 feet. The slope of the hill is 6 degrees. So if I did a little of this action right in there, that would tell me then that this angle here is 6 degrees, right? Which means if I put a vertical tower, what is this angle in there? It's 84 degrees. Okay. If a little bit more. If that angle is 84 degrees, what is that angle? 96. Now, attached to our 100-foot tower are guide wires. Okay? Sometimes you'll hear them referred to as guy wires because guide, when you're speaking fast, just sounds like guy. Okay? That's a wire that's attached to a, oops, I went too far. That's a wire that's attached to something, and it's used for stability. Okay? So there's a guy wire coming down there, and a guy wire coming down there. And it said that those wires were 75 feet up the hill and 75 feet down the hill. It's asking for what the length of each guide wire is. So let's call this one U and this one D. U for uphill, D for downhill. Okay. So D squared is going to equal, oops, tap the brakes. You can have to be that thickness. So D squared is going to be 75 squared plus 100 squared minus 2 times 75 times 100 times the cosine of 96 degrees. So that's going, whoa, jump around. So that's going to be 17,192.9. So my downhill wire is 131.122 feet long. Yes? Now, logically speaking, is the uphill wire going to be the same length? Yes or no? No, 'cause one, it's got a different angle, right? Okay. Logically speaking, is the uphill wire going to be longer or shorter? Shorter, because it's got less of a distance to go. Okay. So my uphill wire, let's put that in a different color. My uphill wire is going to equal 75 squared plus 100 squared minus 2 times 75 times 100 times the cosine of, oops, that should have been 84, not 96. So that's going to be 14,057.1. So my uphill wire is going to be 118.563 feet. Yes? Okay. Now, there are 4 extra problems on the yellow packet that we didn't get to. We might get to some of those tomorrow. There's one more word problem that we might get to tomorrow. So don't necessarily think that we're done law of cosigning yet. Okay? Our plan was to spend half the class tomorrow on law of cosines and then the other half on getting ready for the final. That is the plan.